and it's taken from the IAEA's Current Trends in Nuclear Fuel report, and it shows the failure rate in operations in terms of assemblies per gigawatt produced. It does not cover failures from other scenarios, fuel handling and storage problems. The data only goes back to 1980. It doesn't cover the period before that in the 1970s, and Hinkley B went on stream in 1976. So the retro trends, if you look at it, suggest that the fuel failure rates would have been even higher in the 70s. Therefore, it follows that a risk of contamination through fuel failure by all mechanisms would be higher historically. Even in 1996, where you could consider that fuel failure would be comparatively low, in the UK, Dr. Robert Hawley, the then Chief Executive of British Energy, wrote a letter to the press on the 17th of July 1996, in which he said that the discovery of 1 or 2 failed fuel pins at Sizewell B, is neither unexpected nor worrying. Around the world, such a failure rate is regarded as normal. End of quote. So, pin failure is a routine occurrence. Also consider that in the past, the development of detection equipment has evolved over a long period. The reliance on limited visual inspection has been supplemented in stages by the sophisticated systems available and utilised now, just as the introduction of lithium in the 80s and zinc in the 90s. Further developments have been done to adjust the water chemistry to combat corrosion. That's been incremental. So, as well as the previous drip, drip, drip loss over a considerable time, you should be thinking of what was known and available when Hinkley B first started in terms of fuel performance, leak detection and management, and the safety culture and regulatory oversight that was in place then. You now may feel it's impossible, but back then it was a completely different story. So don't make assessments on the standards of processes of today, which is the impression that you gave in your briefing note. The uranium may have gone out along with all the other discharges. Our findings suggested a land-to-sea transfer mechanism that would suggest this. Moving on to the extent and scope. Yes, sorry, apologies. So lo and behold, this is a very wordy document, so I'll just skim through the main bits. So lo and behold, AMEC did discover elevated levels of uranium on the site, so it is not implausible for uranium to escape into the environment. These 3 quotations are from EDF's Environmental Statement, Volume 2, Chapter 16, Radiological one. So here it says, the top one, to do with the uranium, elevated levels were exceeded. The Environmental Permitting Regulations 2010, but it says that the however, the levels of each of the specified elements were below the radioactive substances, phosphate substances, rare earths, etc. exemption order. Hence, the soils from the 3 locations are exempt from radioactive substances regulation. These sort of things, to me, says that you're not really going to respond to findings of any contamination from enriched uranium, because in your mind, perhaps it's whatever's there is going to be below regulatory concern. Therefore, you don't really need to pay any serious attention to it. So, and as to me, I don't know anything about the regulations, but I do find that exemption orders, if EDF are going to be relying on these exemption orders, basically, to my mind, it's carte blanche to have any contamination on the site. And I wonder whether it is applicable over such a large area. Under the carbon 14 item, it says that it's consistent with the adopted background values. And again, how confident can one be in these adopted background values? So that will be a point for discussion, really, is the question of background values is an important one. In your briefing note, you stressed very strongly that the extent of your monitoring and that any possible leakage and contamination would be picked up quickly, in your words, and that you have always, your monitoring. So I had a look at your monitoring. Your soil sampling, the extent of your soil sampling, they are too few to generate confidence in the status of the land or to confirm a trend suggesting a sea to land transfer. And your decision to just focus on the surface layer, which you did explain, is because in our initial findings we did indicate that, and we didn't have a chance to track down what was eventually found of what was happening on the surface, but so I can understand that. Regarding the possible sea to land transfer, in Hinkley Point B's environmental assessment statement, May 2010, it says that the Environment Agency does not routinely monitor water quality in Bridgewater Bay and has not been able to supply water quality data for the area close to Hinkley Point. So, for transfer mechanism possibility, you're not monitoring the water anyway, so you're not really in any position to say yay or nay whether this is a possibility. The only mention of uranium in the site operator's annual report is in low-level waste, which brings the question in my mind as to what's gone through the incinerators these past 35 years, and hasn't there been a problem with lack of filters or the wrong types in the past? In the Rife report section on Hinkley Point, uranium is not mentioned, and neither is there any awareness of a trend in gamma monitoring around the site, which I'll cover in a later slide. So the scope of your monitoring does have limitations and is not as robust as you suggest in your soil sampling report. So I, as a member of the public, just feel slightly misled by your claims. Who, for example, is comparing these trends? The emissions data is taken from the site operator's own RAD report given to the Hinkley site, the SSG, and the perinatal data comes from the Southwest Public Health Observatory brief. I've just put the two and two together. You're obviously monitoring all the trends, but there doesn't appear to be any crossover studies being done, either initiated by yourselves or by our local health, public health officers. You're not looking at things here. There are studies that have been done in this country that do show that there is correlation with trends. Babies are particularly sensitive to radiological hazards in their environments. But again, in Somerset, nobody's doing this work. In EDF's application, in their health assessment, they just did a desk study. Considering the investment that they've done in their very extensive onshore intrusive investigations, their health analysis was just based on a desk study. But the Environment Agency seems to be, my impression of regulatory bodies anyway, seems to be that you have defined roles and there's not enough interweaving, sharing of information. So I would be interested at one point to know how much, whether these trends are actively done against health populations, sections of the populations, and particularly amongst infants and children, beyond the cancer studies that have been done by South West Public Health Observatory. But cancer, there's a significant delay before that emerges in a population. So I should think this particular aspect to do with perinatal deaths is an infant deaths is worth looking at, and that your data that you gather on emissions should be looked at as a whole in terms of total radioactivity and emission, whether it's tritium, whether it's particulates, whether it's uranium, whether it's carbon-14, whatever's out there, is there a corresponding trend in health? With this prospect of new nuclear build, EDF, as the applicants, do have a duty to really assess the impact that their development would have and what the situation is now. I did not see any information in their application documents to suggest they've done anything more than a superficial desk study. So I would hope the Environment Agency will be doing their bit with the emissions and Andrew from the council to suggest that they revisit this area of health impacts locally. Now, looking at the soil sample locations that the Environment Agency chose for their exercise, coordinates were not supplied, and Brian did explain to me that permission from the landowners had not been obtained for independent people to check these out, because there are a number of what's there. There's no way of checking. So the picture on the screen, as you can see, I just roughly, from the information that was supplied subsequently to your briefing note, you gave direction and distance in kilometres. So I've roughly put them on the radar map, and as you can see, it's arguable as to whether they're actually on the same geology or not. Likewise, on the British Geological Survey map, they have different characteristics. Farm A, for example, when I looked at the OS map as to where I think, following the direction and distance from the site, Farm A, for example, is approximately 6 kilometres to the southeast of the Hinkley Point C site, which I make as roughly close to west-southwest of Cummage. Now, that's a borderline position, as you can see on the geology. But I've accepted that may be on the Lias group, with mudstone, siltstone, limestone and sandstone, and the superficial layer, the BGS said none was recorded. Farm B, which was approximately 11 kilometres to the west-southwest of the Hinkley Point site, that is near to Holford, southwest of Holford, which on the OS map is in a steep-sided, forested valley, which I wouldn't have thought was a suitable place to take background. The geology there is Middle Devonian. Farm C, which was approximately 11 kilometres to the west-southwest of the Hinkley Point site, I've determined is between West Quantock's Head and Bicknoller. And that is Triassic rocks, according to the map, of undifferentiated mudstone, siltstone, sandstone. But that does have a superficial layer of river terrace deposits. So, from the information you've given me, I cannot be certain that it's actually on the same geology. Then there's the choice of farms itself. The application and drift of fertilisers over many years, plus the disturbance and contamination from farm machinery, to my mind makes farms totally unsuitable sites in the first place. And I also note that these sites, all three of them, none replicate AMEX off-site locations for background levels, and I question why not? So the public cannot be reassured by your soil sampling exercise because it fails to deliver acceptable background data. In AMEX characterisation, their surface survey that you find acceptable, over a 15-month period, they chose as one of their off-site background sites the Bridgewater Cemetery. And in my response to their application, I pointed out various reasons why Bridgewater Cemetery was not a suitable site anyway. But here I'm putting the results of their equipment readings. You can see that the G2 numbers over a 15-month period roughly went up over 3,000 counts higher. It went up. This is a significant difference. You wouldn't expect that over just a 15-month period. It's not a normal range from my perspective. Chris obviously will tell me I'm not wrong. I don't know what you can roughly expect, but 3,000 sounds an awful lot to me. Then when you look at the Mini 680 figures, their counts, it's gone down. So it is actually impossible for background radiation to be both increasing and decreasing at the same time. The other sites that you didn't go to for your background were the Wick Park covert that was under trees and British Energy's visiting car park that had shielding. So if all these background sites and readings are acceptable to the Environment Agency, why didn't you go there to get your background soil sampling for your soil sampling exercise? As you can see from the title of this slide, there is a gamma radiation around Hinkley. It shows a trend, a diminishing trend, away from the site. The data is taken from the report on radioactive discharges and environmental monitoring at Hinkley Point A site and Hinkley Point B power station during 2009 that was presented to the SSG in June 2010. It comes in 3 tables. You monitor all this, you've seen all this, so I am assuming that you are aware of this trend, but you give no indication of it. But I'm bringing it up here because, to me, if there is a diminishing trend away from the site, it indicates possible contamination the closer you are to Hinkley itself. Looking back, this is the historical gamma radiation in the 0 to 1 mile range from the Hinkley site. And so, Chris, do you want to chip in on this, comment on this point?
Yes, I think if I don't mention this later on, I should say something about this, because what it shows, and I'll talk a bit about gamma radiation and external radiation levels, but what we see here is an increase in the levels of external gamma radiation as you go forward in time. You can see there that in 1974 it was falling slightly. By 1977 we've got about, according to this, about a 100 nanograys per hour. But now it's reported here that we have less than that, 90 nanograys per hour. But I shall show some. You have just seen some data that says that it's higher than that. So we've got discrepancies between this data and the data that you've just seen. And I'll show you some data that I myself obtained. You know, I came down here with 2 Geiger counters and measured radiation over the site. And we're talking here about, well, according to this, you've got about 100 nanograys per hour, but I was finding up to 210 nanograys per hour on the site. Okay? I'm finding high levels of gamma radiation on that site. And I'll show you a video with this, with coordinates given by a GPS system and 2 Geiger counters showing these measurements. So there are big questions about the gamma radiation over this site that we're talking about. And as far as that's concerned, the reports that I've seen from AMEC are just not believable. They're just not believable, and for the Environment Agency just to accept them in the way they have seems to me to be also quite alarming. Quite alarming. Anyway, I won't interrupt Cecily's.
Well, because the next slide, you may like to make a comment here.
Yes, well, this is a good example. You see, this is the question about the conversion rate for conversion factor for this mini instrument system, which measures radioactivity in terms of counts per second. Now, we're not interested in counts per second. Nobody can convert counts per second into ill health. So what has been done is if you want to look at contamination or consider contamination, what you do is you look at nanosieverts per hour or nanograys per hour. And for cesium-137, there are easy conversion factors. You can convert, for instance, in Fukushima recently, I wrote a paper about this. You can convert 1 microgray per hour into 300 kilobecquerels per square meter of cesium contamination. Of course, it depends upon the particular gamma radiation energy, but if we take about 500, 600 keV as the gamma radiation energy, that is a complete conversion of gamma radiation into contamination. But what we see here is a conversion in terms of counts per minute into nanograys per hour, which is just not reasonable. And what we did is we went to the website of the people who made this who produced this machine. And on the website, when they talk about the machine, in the data sheet for the machine, they give a conversion rate, a conversion factor. And when we apply that conversion factor to the counts per minute that were produced in the report by AMEC, we get a more reasonable result. We get about 150 nanosieverts per hour over the site, which is what I found. So there are big questions about these measurements of exposure rate over the site. The high levels of exposure rate that I measured over the site, and that actually are over the site according to these measurements made by AMEC, properly converted into nanograys per hour, would show that there's significant contamination on the site, and it's much higher on site than it is off site, which is more or less what Cecily's found. And also it's much higher now than it was in 1974. So from all directions that you look at this, we've got too much gamma radiation over that site. And what that means is we've got too much contamination over that site. It's as simple as that. And there has to be some way forward that we can all agree in order to investigate this issue. Because at the moment, it does show that the AMEC results are bogus.
Can I ask that that's minuted, please?
Anyway, if you want to go on, then we'll finish this.
The next slide is, I've done some conversions of AMEC's figures. And it's the 15.7 in this slide that I used in my calculation.
Yeah, this comes from the website of the manufacturers of the instrument, the 15.7.
Yes, Thermo
yeah.
manufacturer's own site. So I took their Amex counts and using Thermo's own formula, calculated what the equivalent would be. Also, when you did the sites, they had quite broad ranges. So just out of curiosity, because they didn't get access to all the land for the whole site, very few readings were done. So what I've done is I've broken it into tens, smaller scales, smaller ranges, and see what pops out. As you can see, the highest is up in the 180s. The highest reading was 187, and they're all clustered round the Hinkley boundary mark, and of course their investigations was that they put that down to the shine from the ISO container that was on the Hinkley A site. But so that obviously is where they focused on. Those were the highest levels. But when you've done it, colour-coded it like I had, you begin to see a different picture. And I am curious as to what is happening with those orange circles that along the southern boundary of the built development area west, that's in the 140s. And they've got some other ones. The southern one that they did pick up, AMEC did pick up, was a different colour-coded things. But to me, that's something fresh and new that I don't think they really covered in their report. And is it suspicious? The other interesting thing is that it's not apparent on the figures that I used to amalgamate. I just put it together for scale, but it is slightly misleading for the councillors and things who perhaps haven't seen it. There are no dots, as it were, on built development area east. It was well surveyed, and they did go through with the Electra, which is the little square ones. But I haven't looked at that because they didn't use the Electra over the whole site. The focus, why I have the title of preconceived ideas, is that they're only interested in where their EPRs are going to be, and where it's known that the asbestos heap was, and buildings, and obviously known human activity. So, but it doesn't jump out at you from a rad characterisation point of view. Ooh, we must go and do all our boreholes and samples up at that end. Apart from the obvious boundary issues, I would be looking at other areas and wondering whether my coverage was good enough in the first place. So my impression is AMEC was not looking fresh at the entire application site in terms of we have to characterise the whole site. They went in purely, they knew what the results were going to be. There weren't going to be any surprises. Therefore, they focused all their main investigations up in the northeast of the site. And I suspect that is exactly the same view the Environment Agency had too, is that you're not looking at the whole site and the needs. To a certain extent, the construction and the excavations involved does make it important that you get it clear. But I do feel that EDF should have done a proper characterisation of the entire site, whether they're going to be digging it up or not. These are the first samples that the Green Audit analysed, just to put some sort of visual aspects to the findings, and to put them in context of where the Environment Agency did their soil sampling. Now, in your wording, you had said, of your report, you said that you used some of AMEC's original locations so that you could compare results with their screening assessments. But you actually only used 3 of the 11 locations, which is hardly enough to really constitute a proper comparison. And 11 barely scratches the surface in terms of coverage over an area that size. So your claim that you could get a good picture of whether there was any contamination or present or not, I don't feel can be upheld. Also, Chris's analysis of the results of that soil sampling, one of them indicates depleted uranium, which is the darker square up in the top left-hand corner. I do feel that there has been a lack of consultation over this. The Environment Agency is signed up to Safe Grounds, and one of its principles is to engage early participation of stakeholders, but that hasn't happened. Even the Environment Agency's own internal guidance recommended doing the same. A whole string of decisions were made all the way along that you have not included either us, or the campaigners, or local residents. And even though I contacted my councillors and the campaigners I knew, and also Jonathan at the Marine Management Organisation, to invite them to attend, you on your part have not extended invitations to representatives of the local residents living close to the site and who most probably would have been interested in coming today. I also feel it's telling that you opted to take soil samples instead of calling Chris Busby in to thoroughly investigate the details and evaluate his analysis through dialogue. Instead, you demonstrated, to my mind, a classic Semmelweis reflex by issuing an immediate rebuttal. This was possibly more alarming than the findings themselves. However, you have agreed to this meeting, and for that, it's... You've thrown me now.
Sorry. I just thought that point about lack of engagement.
Oh, right, yes. Yes, no, there is. It's the lack of engagement so far has eroded confidence and trust. And I also feel that the fact that you did take samples at all proves that you don't trust AMEC's work either. But, you know, you have agreed to this meeting, and for that I am actually very grateful. Thank you. I know the Environment Agency, the next item is